Okay, we're going to look now at the geometric sequence. We had a look in the last screencast at arithmetic sequences. The feature, the distinguishing feature of the arithmetic is that there's a common difference. Now for the for the geometric sequences have a common ratio that we call R, surprisingly. And in the simplest terms, take any term, divide by the term immediately before it, you'll get R. And if that's the same for every pair of terms, any pair of terms in a sequence, then you have a geometric sequence. Now, we know that U1 is the first term and that R is equal to the common ratio. So therefore we have the first term is U1, and then the second term U2 is U1R, and the third term is U1. We just keep multiplying by R, and if we keep going like this, we'll spot a pattern. All right, all I'm doing here is we started with our first term, so this is the term number here. Right, this is the term number, and this is the actual term. Right, so the term number is the first term is U1. The second term is U1 times R. The third term is U1 times R squared. We just keep multiplying by R. That's the rule with the geometric sequence. But what I'm interested in now is what happens as we progress this to UN. And if you remember back to arithmetic sequences, we did the same thing. We went through and found our nth term, didn't we? So we had a little look at the rule, and there it was there. First term, second term, third, fourth, all the way to UN, and we discovered that it was always U1 plus just one less than this times D. So we came up with a formula. The nth term equals U1 first term plus one less than that times D. And that enabled us to do all sorts of stuff. So with geometrics, what is it? Well, it's, look at this. We've got U2, look at the power of R. U3, have you spotted the similar pattern, isn't it? But it's always U1 by R to the 1. This is 1 less than that. So how do I write 1 less than n? N minus 1. Here we are. We've got ourselves another formula. So for geometric, the nth term is equal to U1 R to the n minus 1. Okay, now that's to go with our arithmetic sequence rule, which was UN equals U1 plus n minus 1D. As I said to you before, these are all on your formula sheet when you get into an exam. So now let's use this. So I'll just put a couple of examples up. Okay, straightforward example here, the ninth term of this sequence, 1, 4, 16, 64. You can see with geometrics, they grow, don't they, a lot faster. So this is going to be a lot more useful. We're also going to need use of our calculator, I think. So the ninth term. Well, let's start with what we know here. So this is what we start with. So the ninth term is going to equal the first term, U1. There's U1 there. All right, that is U1, the first term. What's our common ratio here? 4 divided by 1. 16 divided by 4. It's 4, isn't it? Right, so the U9 is going to be U1, which is 1, times R, which is 4 to the power of n minus 1. Now, n in this case is 9, so that's 4 to the power of 8. Okay, 4 to the power of 8. I don't know that off the top of my head, so I'm going to go in here and find out what 4 to the power of 8 is. 65,536. 65,536 is the answer to that, the ninth term. Okay, let's do another example. I'll pause. Okay, here's the question. The 12th term of the sequence 7. Okay, let's start to label some of this stuff. That's my U1 there. Now, what is my common ratio or common? I don't know what it is yet. We've got to identify it. We've got to establish whether it's arithmetic, geometric, neither, before we can do anything. Divide minus 14 by 7, you get 2. Divide 28, do you? You get minus 2. 28 divided by minus 14, minus 2. Minus 56 divided by 28. Right, so my r is equal to minus 2. I have a geometric sequence. The 12th term, so now I can use this formula. The 12th term is u1, 7 times r, which is minus 2, to the power of, what does it say? N minus 1, 1 less than the term I'm looking for. So 7 times minus 2 to the power of 11. Let's get the calculator out. 7 times, and let's make sure we bracket our, there is the bracket, our negative 2. Negative 2, get outside the bracket now, to the power of 11. And hit enter, minus 14,336. Minus 14,336. Can you see how powerful this is? Now we're very quickly coming up with a certain term in the sequence that large numbers, it's not taking us any time at all. Okay, next example. Okay, here we have a question similar to one of the examples in the arithmetics, and that we're given two terms, and the numbers in the first term is 864, the fourth term is 256. So we're given the value of a couple of terms, and we're asked to find out some information. So this says use simultaneous equations. So we're going to write these, use simultaneous equations. Whenever you get this information where you're given some information about two terms and asked to find something out about them. So u1 is 864, that's useful. All right, u4, let's write u4 down. All right, u4, which is 256. All right, now u4 is u1, 864 by r, which we're trying to find, to the power of 3, isn't it? 864 times r to the power of 3. So we can get from this, in fact we don't need to use simultaneous equations because one of the terms they gave us was the first term, so that gave us one of the variables straight away. Usually, if this said u4 is 256 and u8 is something else, we would have had to have solved simultaneously in order to find out what u1 and r were. In this case though, we're just going to take r cubed, divide both sides by 864, so 256 over 864, what's that? 256 over 864. Let's get ourselves a little 256, tab, 864, hit enter, and that's 8 over 27. Thought it might come down to something nice. That's just 8 over 27, they're both cubic numbers, so r will just equal 2/3. That's our common ratio, and that's what we've been asked to find. We'll have a look at one more example. Right, let's have a look at this one for the geometric sequence 5, 15, 45. We can see, can't we, that our r is equal to 3 and our u1 is equal to 5. Our u1 is there 5. Find the least value of n such that the nth term is greater than 50,000. Right, what are we going to do here? Well, we don't know what n is, so we're just going to write un equals u1, 5, times r, which is 3. I don't know what n is, the n minus 1. I need to find this out such that that is greater than 50,000. Okay, well, there's a couple of things we can do here. We can just get our calculator out and go 5 times 3 to the power of, and guess some numbers in here until we get above 50,000. Or we can graph it. They're the two options. So 5 times, we can just go in here and go 5 times 3 to the power of, and just guess some numbers, and see how we go. So if I guess 10, 295,000. I'm a bit too big there, so I'll go back up, use the arrows to get that, hit enter, and it copies it back. So now I will change that 10 to say an 8. Right, now we're too low, 32,805. So again, copy back. So it's just a bit of hack work, but I'll now go in there and choose 9. I think 9 is going to be the first one above 50,000. You see the jump there from 8 to 9 got us above 50. So since 5 times 3 to the 9 is the first greater than 50,000. So this is the value of 9, therefore n minus 1 has to equal 9, or n is equal to 10. So that's find the least value of n equals 10, such that the nth term is greater than 50,000. So it'll be the 10th term that is the first above 50,000. I did say we could use a graph for it. I'll show you quickly. Go back in here and graph it. So we'll just put in here 5 times 3 to the power of. Now we could just put a little x in here, and we could probably put a -1 in as well. And we're going to graph it. But actually what I'm interested in is going to the menu and choosing table. And what we'll see here is it'll give us values of, over here in the left column, the values of x. And we're looking for the first value to be above 50,000. 32, there it is, 98. 32 is below, 98 is above. There's our value of 10. Remember I graphed x minus 1, so there's my value of n that we're looking for in the problem. Excellent. Okay, so I think we're good now to proceed with exercise 6. We've done ABC with arithmetic. I think it's D and E, and we'll enjoy those when we get into class. See you soon.